Okay, today's video lesson is going to be on buffers or buffered solutions. Essentially what a buffered solution does is it allows a solution to maintain its pH. So what's going to happen is we're going to add hydrogen ions, which make a solution very acidic, and hydroxide ions are going to make it very basic. But what the buffer solution does is it will absorb these hydrogen and hydroxide ions without allowing the pH to change drastically. Now this is very important for a lot of different systems. For example, your blood is an example of a buffer system. Your blood has to have a pH maintained of about 7.35 to 7.45. If your blood pH changes drastically, if it goes up or goes down, you doesn't have to go drastically change, just a slight change in your pH. If it gets too low, you get what's called acidosis, and if it gets too high, you get alkalosis, which both can essentially kill you. And you can get that by having hydrogen and hydroxides being put into your blood system. How do you get those in your blood system? Well, by different things you eat and by breathing and all this other stuff. But your body has a way of maintaining that pH, that 7.35 to 7.45 range, by having a buffer in your blood. An example is like, let's say we have a solution here of just pure water, just H2O. Okay, nothing in here, just water. If I were to dump in hydrogen ions, originally the pH is going to be 7. Okay, so my pH of pure water is 7. But if I dump in here hydrogen ions, like let's say I add HCl, like a strong acid, well, my pH is going to plummet. It's going to go down to like really, really low pH of like 1.2 or something like that, depending on the concentration of the acid. So we know that if I add an acid to pure water, the pH is going to drastically go down. If I add a hydroxide, like something like sodium hydroxide, to the pure water, well then what happens is my pH drastically goes up, and I get a pH that gets close to like 13 point something. Okay, so we can see that just adding pure, acids and bases to pure water drastically changes our pH. Now, if we have a buffered solution, and we say that the solution here is now buffered, what that means is it will now maintain a pH. So let's say we buffer it at a pH of like 4.34, okay? And I add a hydrogen ion to the solution. Like now we add HCl. Now the pH is still going to drop, but it's not going to drop that much. The pH is going to drop to something like 4.32. We might even drop down to like 4.12 or something. It depends on the concentration of the acid you add. But the point is that it doesn't drastically change like it does just in the pure water. And the same would happen if I added the sodium hydroxide. If I added sodium hydroxide, pH is going to go up, but it's not going to go up drastically. It's going to go up to like 4.75 or something. Okay? So that's the idea behind a buffered solution. It keeps the pH roughly the same value without changing it drastically. Okay, so how do you create a buffer solution? Well, to create a buffer solution, you have to have one of two setups. This is what's considered an acidic buffer. Okay, so this would be my acidic buffer, and an acidic buffer would have to have something like a weak acid, okay, and a salt containing the conjugate base of that weak acid. So, for example, let's do an acidic buffer example. What I would have to do is I have to choose a weak acid. It cannot be strong, and I'll explain why it can't be strong a little bit later. Something like HF, okay, and I would have to have a salt, so I could choose something like sodium because it typically dissolves and dissociates and it doesn't do anything, and I would put fluoride. So this would be my buffer solution. So what you're looking for is a weak acid and a salt containing the conjugate base of that weak acid. Another example could be something like HCN, hydrocyanidic acid, and what I could then add to that would be lithium cyanide. Right? Again, weak acid, salt containing the conjugate base of the weak acid. Now to make a basic buffer, what I need to do is I need to add a weak base. Now typically the base that I add would be ammonia, and what I would add would be ammonium, and I would need something because ammonium is going to have that positive charge. I'm going to balance that charge because it has to be a salt. So it's ammonia with the conjugate acid of that weak base. Okay, conjugates are really important if you haven't noticed in the last couple units. Okay, all right, so let's take a look at how buffers work. Okay, so let's say we have our buffer solution. All right, we have the buffered solution, and what I'm going to do is I'm going to start with an acidic buffer. Okay, so I'll do an acidic buffer. Okay, so acidic buffer. And the buffer system that I'm going to work with will be HF and sodium fluoride. Okay, so I'm going to show you some examples on how to do the calculations with this later. For right now, we're just looking at how they work, okay, without really getting into the calculations. Now, what you want to do is list the species that are present here. So list the species that are present in this buffer system, which would be my hydrofluoric. Now I write this as a molecule. I don't write this as ions because it's not a strong acid. If we're a strong acid, I'm going to write the ions out. And I would have sodium, and I would have fluoride, and I have water. Okay, so those are the four things that I have in my buffer. So this is essentially the buffer that I have going on here. So this is my buffered solution. Okay, what I'm going to do is I'm going to come in here and I'm going to add an acid. I'm going to add HCl to the solution. So what I now add is H plus, and now I add Cl minus. Okay, now here's where it gets the chemistry added. Okay, here's what we're going to think about chemistry. We got our weak acid, so I'm going to identify that as an acid. Sodium ions don't do anything, right? You ignore the sodium ions. Fluoride is considered a conjugate base. It's really more important that you recognize that as a base. This here is water to neutral. Doesn't really do much in this problem. It will in certain points, and we'll get to that a little bit later. This here is an acid, and it's considered a strong acid because it comes from the hydrochloric acid. And you'll hopefully remember that chlorides don't do anything, right? So those anions and the cations from our strong acids and our strong bases don't do anything. It's just those weak ones that are going to have any sort of effect. Okay, so what's happening here? What's going on? Well, if I have an acid and an acid, not much is happening. It's just a mixture of acids, not a big deal. But here I have a base, and the base is going to react with the acid. So what happens in this buffer solution is that the fluoride ion that I have here is going to react with that H plus ion, and as a result, no equilibrium because the reaction goes to completion because this is a strong acid. It's just completely ionized. What I'm going to get is HF to form. So notice what happens is that as this hydrochloric acid is added, this hydrogen ion is not free to just go through the solution and make the pH change drastically. It's going to keep the pH maintained because as soon as that H plus ion hits the solution, these two react immediately, removing that hydrogen ion and making more of the hydrofluoric acid. Okay, so what happens is my concentration of the fluoride goes down, the concentration of the acid goes up. Okay, and that's how we would absorb an acid being added to this system. Okay, now let's take a look at what happens if I add a hydroxide. If I add OH minus now to the solution by adding sodium hydroxide to this, if I add sodium hydroxide, what I've now done is I've added OH minus. So let's go ahead and take a look at what happens with that. Let's get rid of this. Let's think about the species that we have present here. Again, the species we will have would be the buffer system, of course. So we can have the HF hydrofluoric acid, the sodium ion, my fluoride ion, water, and now this is my buffer. So don't forget that's the buffer. What I have now added is I've added into this buffer sodium ions and hydroxide ions. Okay. Well, as I said before, sodiums don't do anything, so you can cross those off right away. Again, this is my acid. This is my base. Now this is considered a base, and again, it's a strong base. So the reason why we want to know that's a strong base is anytime you have the strong bases and strong acids added to the solutions, you're always going to go to equilibrium. Okay, so you're always, we're going to see that when you do the calculations a little bit later. So just like we saw before, what is this base going to react with? Well, the bases react with acids. So in this case, what I'm going to do is react HF, the hydrofluoric acid, with OH minus, right? And if I react these two together, this is the acid, it loses it to the base. What I end up with is water, so I get more water, more HOH if you want, and I leave behind my fluoride ion. So notice the opposite effect that happens here. In this case, my fluoride ion is going up, while my acid is going down. And this is the concept of buffers. What they do is they have a balance between an acid and a base. That's the whole idea, is that I have an acid in my solution and I have a base. The acid is in there to absorb any base that's added, and my base, my conjugate base, is in there to absorb any acid that's added into the system. And that's essentially how an acidic buffer works. Okay, a basic buffer works pretty much the same way. The components inside that basic buffer are going to be a little bit different. Basic buffer, if I can get to right. So a basic buff, what it's going to have is essentially in here you'll have something like NH3. That would be your base. You have NH4 plus and your Cl minus. Cl minus doesn't do anything. It's really this here. So this NH plus, the ammonium, is going to be your acid, and this acts as your base. So if I add H plus in here from HCl, well, the acid is going to react with the base. If I add OH minus by putting in here sodium hydroxide, well, this is then going to react with the acid, and you can write those two reactions out, okay, and see the way that works for yourself. But it's pretty much the same general concept. All right.